Science is supposed to explain everything: gravity, light, time, life itself. But every now and then, nature does something that makes scientists stop and say, "Wait, what?" These are the moments when it feels like nature breaks the laws of science.
The laws of science aren't commands etched into the fabric of the universe. They are our best, most elegant descriptions, our attempt to map an infinite and complex reality using the tools of observation and mathematics. For centuries, Newton's law of universal gravitation was the bedrock of physics. It predicted the fall of an apple in the orbit of the moon with breathtaking precision. It felt absolute. But then, Einstein revealed a deeper truth. Gravity wasn't a mysterious force pulling objects together, but the very shape of space-time being warped by mass and energy. His theory didn't just refine Newton's, it completely reframed our understanding, explaining anomalies that the old model couldn't. Similarly, the seemingly unbreakable laws of thermodynamics were later understood as statistical probabilities, the predictable outcome of countless chaotic particles. Each new discovery shows us that what we call a law is simply the edge of our current understanding.
So when nature appears to break the rules, when we observe something that defies our neat equations, it's a profound moment. It's an invitation. It tells us that the map is not the territory. It's a sign that we're standing at the threshold of a new discovery. It's not the universe that's wrong. It's our rulebook that's beautifully, wonderfully incomplete, just waiting for the next chapter to be written.
Sometimes the rule book of science seems written in pencil, ready for nature to erase and rewrite. Consider the platypus, a mammal with a duck's bill that lays eggs and even glows under UV light. For decades, it was a living paradox that defied classification. This defiance isn't limited to the animal kingdom. In the deep ocean, life creates its own light through bioluminescence, a cold chemical glow illuminating the abyss. It's a biological magic trick. Then we have materials that seem to cheat physics. Superconductors allow electricity to flow with zero resistance, a feat once deemed impossible. And now, we're engineering metamaterials, substances with properties not found in nature, capable of bending light in ways that could one day lead to invisibility. These aren't violations of natural law. They are invitations to understand it more deeply. But the most profound challenge comes from the quantum realm. Here we find quantum entanglement. Imagine two particles, linked at their creation, sent speeding in opposite directions. The moment you measure a property of one, you instantly know the state of its partner, faster than light could travel between them. It's a connection that defies our classical understanding of space and time. Albert Einstein, deeply troubled, famously dismissed it as spooky action at a distance, convinced there had to be hidden information. Yet, experiment after experiment has proven this spooky connection is real. Nature isn't breaking its own rules. It's revealing that the rules are far more intricate and mysterious than we ever imagined. The universe plays a deeper game. Take black holes. According to early physics, they simply shouldn't exist. Singularities of infinite density where the rules of gravity and time collapse entirely. Even Einstein was skeptical, yet they're out there, cosmic leviathans silently devouring entire stars. Or consider dark matter, an invisible substance that makes up most of the universe's mass. We see its gravitational fingerprints everywhere, holding galaxies together, but we cannot touch, see, or measure it directly. Science can describe its effects, but not its essence. And if that wasn't baffling enough, dark energy is actively pushing the very fabric of the universe apart, causing its expansion to accelerate in defiance of gravity. From the deepest voids, we even detect fleeting, powerful signals, fast radio bursts. Millisecond-long flashes with more energy than our sun emits in a day. Their origin remains one of the greatest puzzles in modern astronomy.
We build our models, we write our equations, but the cosmos isn't obligated to follow our rules. It's as if the universe deliberately keeps secrets, profound and humbling, just to remind us that we are not the ones in charge. We are merely the observers, standing at the shore of a cosmic ocean. trying to read a book written in a language we've only just begun to decipher.
When nature breaks our laws, it humbles us. It tells us, your understanding is temporary. Every mystery, every paradox, is a doorway to a deeper truth. The world isn't broken, our perspective is just too small.
That's not a failure of science. It's the beauty of it. Because every law shattered is a discovery waiting to be made. So does nature really break the laws of science? Maybe not. Maybe it's simply reminding us that it writes the laws, and we're still learning how to read them. Because the universe isn't finished revealing itself. Not yet.